Today's announcement is one, I will start making the list of the syntax, the StackCrunch syntax that if you remember in your midterm, you receive midterm syntax, how you use your StackCrunch syntax, how you use your StackCrunch, right? Doing to perform things that are asking you to do. So I would start doing it today. So you probably will get it on next week. I think it's Monday. And I will, if there is anything missing, I will update that list. Who knows? Sometimes I miss some command or some stuff in StackCrunch. So I will be doing that. Second announcement is you have 4 homework due next Wednesday, 71728182. So start working on your homework here. Okay. So today's class is we will be continuing 8.1 here. How do we perform hypothesis testing here? So we did step number 1. We go through there are 7 steps to 7 steps procedure to go over a hypothesis testing. So we did a few steps already. So the first step that we talk about is to requirement check the requirements here. Second step is to state your hypothesis. Third step is to figure out the sampling distribution. Fourth step, this is where we stopped yesterday, is to find a critical region, significant level, critical value, and p-value. So usually significant level is what we call as a confidence level. You do not need to find it. Usually significant level alpha is given in the question. Okay. So usually alpha is given in the question, so you do not need to find it. Okay. Critical region is just an area, so also this one you do not need to find it. Okay. Usually that's the shading region that you see in the in your every time when you draw the left tail, right tail, the shading region is what we call as a critical region or rejection region. Critical value is the value that is right in the middle, a value that is separating between significantly high and no significant. So we don't use the word significant high and no significant anymore because in this when you do a hypothesis testings, the shaded region is when when we call it rejecting the null hypothesis. So this is where you reject the null, and then this is where you're gonna accept the null. Okay, but in order for you to find the critical value, this is how we do it. So this is the second page that we have here, and I am going to be really just be honest with you. This whole entire second page, Oops, sorry. Yep, the entire second page is important. Okay, the entire second page is important. So this, make sure you have that. Okay, so I call this 8.1 second page. 8.1 second page. This is very important. So that's the reason why that there you go. So I'm going to add another one. So we are adding quite a few things here. A bit closer here. 8.1 second page. So this 8.1 second page that I mentioned, which is this one that I draw in green here, is so important that the finding critical values, finding p-values, and the conclusion. So there are 3 tables here. These 3 tables are super important, and especially the last table here. This is used when we do a hypothesis testing for doing step number 6, drawing conclusion. And this is used in almost from now towards the end of the semester. So we will be using this table, the conclusion table that we have here, the last table here. That is the most important table that will be used. And make sure you guys, I don't want you guys to memorize it, but I just want you guys to know how to make sure you know how to apply it. Okay, because if this is you should able to do that. That's what is super important here. Okay, so the first table is what we call as finding the critical value. So this is the first important table here. Now we did show you how to find critical value in 7.1. If you remember, in order for you to find the critical value, number 3 in red here, you find out that this is a little bit different. Now, this is how you find the critical value for confidence interval. Okay. Now, the one that we're gonna do here is finding critical value for hypothesis testing. So there are two types of critical value that you had to find. So one of them is the one that you just did on 7.2, the one that I've marked in red, how to find critical for confidence interval. However, in this table, this is how you find a critical value for hypothesis testing. It's not much different in this case. The only difference here is that now we don't have a two-tailed test. We have 3 types of tests in this case involved. So when you guys want to find a critical value for hypothesis testing, the first thing you ask for is, are we doing population proportion or are we doing population mean? Okay, if you are doing population proportion, then we are doing what we call as a normal calculator. So if you are doing population proportion, we are doing normal calculators. But if you are doing mean, the one in green here, then we're going to use a T calculator. Okay, so this is something that we're going to use here when the question asks for critical value. So now if you are population normal calculator, mean is, make sure you the normal calculator with the mean 0, section 1, which is, we call it the Z distribution. For a two-tailed test, so now depends on what kind of test we have. For a two-tailed test, make sure that your alpha in this case is going to be over 2. Okay, so for two-tailed test, make sure the alpha here is over 2. So you notice that no matter it is a proportion or mean or normal or T distribution, make sure that the two-tailed test alpha over 2. And the reason why it is alpha over 2 is because you break it into 2 pieces. So alpha is a shading area. So if you want to find, example, a 95% confidence level here, then this alpha will be actually shared by these 2. Now, since it is a symmetrical distribution, so this is going to be divided by 2. So you find out that when you do what we call as a two-tailed test, when you look at the alpha, the significant level, it is divided by 2. So that's the reason why that when you have a two-tailed test, this is divided by 2 here. Okay. And also I want to point out here is when you do the two-tailed test, your stack crunch only give you either the positive or the negative value here. So you have to, your answer in this case will actually have to put a plus minus. So so make sure you know that your stack crunch does not do don't have plus and minuses. They only do either pluses or minuses. Depends on what symbol you use. So if you use a greater than symbol, then your test, your critical value in this case will be positive. Okay, just want to point to you. And if you use a less than or equals, you can still use it to less than or equals less than or equals to symbol. Then the only difference here is your critical value will be negative if you do this case. So but make sure you know that it has both sides because it's a two-tailed test. Okay. The next one is a left tilt test. When you do perform a left tilt test, then we don't divide the alpha over 2. We use the whole entire alpha here. But you notice that this fellow, you have to use less than. You cannot switch it to greater than. The reason why is because when you have a left tilt test, your shading area is on the left side. So that's the reason why that when you want to find the critical value must be on the left side. So it means this must be less than or equals to. And when you figure this this critical value here, your answer has to be negative. Okay, just for the left tail test. And then for the right tail test, we're still going to use alpha. The reason why is because it is just one tail. So that means that the whole area will take the whole alpha, 5% if you use 95% confidence level. But for the right tail test, we will only use the symbol greater than or equals to. We're not going to use less than or equals to. And your answer in this case is always going to be positive. Okay, so this is how you find the critical value. So when you guys do chapter 8, chapter 9, chapter 10, if the question asks for critical value, make sure you refer to it. Okay, so this is the kind of like a important page that you need to know. Okay. Now, so sometimes the question here wants you to find a p-value. Okay, so this, don't forget, this is still in question number step number 4 here. So I'm giving you all this is because sometimes the question wants to find the critical value, sometimes the question wants you to find p-value, or sometimes the question wants you to find alpha to figure out what is alpha is. So these are the stuff that you but so you have to figure out how to do those. But alpha in this case, usually you do not need to find it. It has to be given in the question. Okay. Now, the next definition we're going to go over is p-value. So this is very important because as you guys know that there are few methods to test a hypothesis testing, but we are only concentrate on the p-value method. So this is what is a p-value? A p-value is a probability of getting a value of a test statistic that is to the extreme as one can represent the sample data, assuming that the null hypothesis is true. So p-value in this case is actually a probability. Now, and you guys know that since probability has to be between 0 and 1 included. So in this case, your p-value in this case must be also in between 0 and 1. That means that if I found out your p-value is less than 0, is negative, which is or above 1, then I know your answer is wrong because probability is always between 0 and 1. You cannot go above it. Okay. How do you find the p-value? So again, we will break this into 2 pieces. Either we are doing proportion, where you do the normal calculator, or either you do population mean, then you will use the T calculator. And you find out that for this case, we also have the test. So two-tail test, left tail test, and right tail test. Now, for the two-tail test, you need to double the probability next for this case. So when you do find the p-value, make sure you double it. And if you use greater than, then this z-score has to be positive. Okay, so so just want to point out to you that so if you are using greater than symbol, then make sure that the z or the t-score that you use here has to be positive. What happens if your z-score is negative? Okay, so if the z-score is negative, you use less than or equals to. Okay, so you use the change the symbol to become less than equals to if the z-score is negative. So so make sure you got the z-score will be provided in the question. So you just need to figure out which one to use. Should we use the greater than or equal to or less than or equal to? This is all depends on the z or the t-score, depends on which one you use. And if it's a positive, make sure you use greater than or equal to, because that means they are shading on the right side for the positive value. And t-score is on the negative, so we always go to the left side. However, for the one-tail test, for a left tail test, it has to be less than the t-score or the z-score. And for the right tail test, the symbol has to be greater than. Okay, so make sure you guys know this. This is quite important here. I will give you some example in this case. So this is how we do step number 4. Okay, so step number 4 is quite a lot here. So we'll come back with number 3 in your example. So we're gonna go for example 4 and example 5. So in this example, the question asking us what kind of test is that? Is that a left tail, right tail, or two-tail test? And then the question wants you to find the critical value. And then the question also wants you to find the p-value. Okay. And then there's a lot of question here. Oh, decision. Then they ask you to figure out what decision it is. So there are 4 things that this question wants us to do. 1, what kind of test is it? 2, find the critical value. 3, find the p-value. And 4, find what is the decision. So when you do this, in your homework, make sure you figure out which one it is. So if you're asking for left tail, right tail, two-tail, make sure you look for your what kind of alternative hypothesis. Because if you use less than, it's left tail, right greater than for right tail, and not equal to for two-tail. And then if the question also asks you to find the critical value, so this is the first table you use, and then find the p-value, which is the second table to use. And then now is a decision. I forgot to do the decision piece, but I am going to do the decision piece right now. How you make a decision here? You make a decision based on the p-value and the alpha. Okay. So the p-value, if the p-value less than or equals to alpha, we will reject the null hypothesis. That means that if you are rejecting the null, in this case, means you are taking the alternative, each one. So that what does this mean is when you find out that your p-value is less than alpha, so what we do here is we will be rejecting the null hypothesis. So if you reject the H0, then we will definitely have to take the H1. Okay. However, if your p-value that you found out here is greater than alpha, and alpha is a significant level, then we fail to reject the null hypothesis. Okay, so this case that you are taking the H0. So as you guys know that either you will you're going to take one of these hypotheses, this statement, either the null or the alternative. So how do you know which one you take is depending on the p-values and the alpha. So that is what we call as a decision here. We don't use the word accept. Okay. We don't use the word accept in this case. Some of you will say fail to reject. Kind of like accept, right? So in this case, please do not use the word accept to replace fail to reject here. The reason why we don't use accept in this case is because we are not 100% confident in this case. Okay, so that's the reason why that we do not use the word accept in this case, because of we are not 100% confidence to accept this. We are only 95 or 99% confident. So accept is a very strong word. So we replace it with fail to reject the null. So this is mostly all the statisticians are using this word here. So you won't see the word accept in this case. Okay. So this is a step number 5 is decision. I'll just go through all these 7 steps here, so you guys will go through that. And step number 6 in this case is gonna be conclusion. Again, these are important. And in order for you to draw the conclusion, this is one of the these are the 4 different conclusions you can use. Okay, so it can be conclusion number 1, conclusion number 2, conclusion number 3, or conclusion number 4. Okay. Now, I will tell you that if you read through the condition, it's a lot of work. So I'm gonna draw how a flow chart, how you make this conclusion. So so that means that is that number 1, or is that number 2, or is that number 3, or is that number 4? So first thing, when you want to draw a conclusion in this case, we will have to use what we call as uh, your claim. So first thing you ask yourself is your claim statement. So is your claim statement has equality, or your claim statement has less than, greater than, or not equal sign? Okay. So when I say the claim statement in this case means that the original claim statement. Again, you will learn all this. And also you'll be like, I think David is teaching Chinese today. Okay, or this few days, yesterday too. So yeah, you will learn all this later on. So make sure you guys be patient, and this is very difficult material here. And if your claim statement does have equality, then you look at your decision. Do you reject the noun, or you fail to reject the noun? I'm going to use short form here. If your claim has equality and you reject the noun, so you will have to pick the third conclusion, which is there is sufficient evidence to warrant rejection of the claim. And then this will be the one that you pick. If you take the, if your claim have equality and you fail to reject, you will do the fourth conclusion, which is this: there is not sufficient evidence to warrant a claim that. So this is the conclusion you will make. Again, you will also have this choice: either your claim is this or that, right? So if your claim has the inequality one, less than, greater, or not equals to, then you also can either reject the noun or fail to reject it. Now, if you have this case, you will pick the first conclusion, where this is where there is sufficient evidence to support the claim. However, if you failing reject the noun hypothesis, you are picking the second conclusion, which is this below. There is not sufficient evidence to support the claim. So this is how I will show you some examples, so you will know what is going on here. Some of you will be asking me, was like, David, totally Chinese today? Okay, which is fine. I mean, don't worry about that. You will learn this. Okay. First, you're probably first time seeing it, so it's a little bit. Okay. So once you finish making a conclusion, the last one we're gonna do here is making what we call as the answering the question. This is the last we will be doing. Answering the question usually consists of a few things. One is sometimes they want you to answer the question. Okay. If the question is asking you to please answer the final questions or the questions that is asked, usually either the answer in this case is either yes or no, and it is depending on your conclusion. Okay. So if so in order for you to answer the question yes or no for this case, you depending on what questions we have here. So what conclusion you made. So if you're making the first conclusion, then your claim is valid. Okay. So so that means that usually the question will be yes. Okay. So again, when you have a claim that's valid, means usually is yes. Because if you read the conclusion here, it is all positive. So that's good news. However, if you read, if you do the second conclusion, then the claim is invalid. The reason why the claim is invalid in this case is because there is the word not over here. Just want to point out to you, so you know that so the claim here will be not valid because it is the conclusions not supporting the claim here. If you do the third conclusion, the claim is also not valid. Okay, so invalid in this case. Why the claim here is invalid is because of the word rejection. So those are all what we call as negation word. So so the word not is negate, the word reject is negate. So that's why we use the word reject here. However, if you did the fourth conclusion, the claim in this case is valid. Okay. The reason why this claim is valid is because of the double negation, not and the word reject. Okay. So this is kind of like back in your algebra class, you got two negative, and you know that when you have two negative and you multiply, it become positive. So this is what happens here when you draw this conclusion. When you got two negative, this claim will be valid in this case. Okay. So usually when they ask you to answer the questions, you just figure out if the claim is valid or not. Okay. So this is what usually one of them. Okay. Claim is valid. Okay. So that's one way to answer the question. The second way to answer the question is to give other factors that affect the result. Okay. So example is there are other so when you talk about let's say to prevent safety, we will for riding the motorbike, we have to study just people, how many people are texting, but you guys know that texting is not the only cause of having a car accident. So and you do the whole 7 steps analysis here, and then sometimes the question will ask you, can you give me other factors that will also cause accidents to to go up or down? Beside, yeah, texting is one of them. So you can say about like the age of the driver, or you can talk about if the driver is DUI or having no license, or no, those kind of other factors that you have. So those are what they will ask for. So this give other factors is something that you have to think outside the box, which I cannot teach you here. So just give but I only need not plural, I just need one. Okay, so I just need one of them. So in the test, if I do ask you to give me any another factor that will affect this result, don't be greedy, give me a lot. Just give me one factor would be good enough. You cannot think a lot, it's fine. Just one is good enough. Okay, so this will be the 7 steps. So the last step in this case. So let me go through this 7 steps procedure so that we learn all 7 steps. First step, requirement check. So there are 2 requirements here. Second step is to perform state the hypothesis statement. So we have the null and the alternative hypothesis. Third, figure out the sampling distribution. So the sampling distribution can be either Z or T distribution, depending on what kind of population parameter you're using, either proportion or mean. If its proportion is Z, mean is T. And then the next one we're going to do is to figure out the test statistics and the critical value and the p-value. Depends on the questions. Test statistics will be provided by StatCrunch. Critical value and p-value is found using these 2 boxes. Okay, box. I will say not boxes, I use table. So I'm going to call this now table A. Or table 1. Let's do table 1 here. And this is going to call as table 2. And the one underneath that will be called table 3. So I'm going to label these 3 tables here. So so table 1, 2, 3. So 1 and 2 is to find the critical value. Table 2 is find the p-value. Step number 5 is to make decision. Your decision have only one. Either you reject or fail to reject the null hypothesis, depending on the p-values. So if the p-value is less than alpha, we will reject the null hypothesis. This means that you will be taking the alternative H1. However, if you do p-value greater than alpha, we will fail to reject the null hypothesis. If you're making this decision, means you are taking the null hypothesis H0. For conclusions, there are 4 conclusions here, depending on how you which one you pick. And the last step in this case is to answer the questions. So make sure sometimes the answer question is asking for is a claim is valid or not. So you have to look at what conclusion you've done or give other factors in this case. Okay. So this is the 7 steps procedure here. So you will be doing this from now on till the end of semester. You'll be getting, first time you learn this is a bit hard, but once you learn this you're getting like used to it. Okay. Now there are some notes that I want to point out here. We will not gonna use the word accepting. I think I mentioned that already. We don't use the term accept. It's because that we are not 100% confident with it, and we are not have never proven now. So it's a misleading thing that we will not use in the world of statistics. And also watch out with the multiple negatives. So remember last time that the word not is a negative word. Okay. The word reject is a negative word. So if you have 2 of this, then it will become a positive word. The word ban, the word yet. So there are some other words that if you use it, it means it's a negation statement or negative statement. So that means it's automatically is opposite. So when you have a negation, when you answer no, means it's yes, and yes means no. So that's why you have to watch out for these multiple negative statements here. And the more you have, it's like the more negative you add to your multiply. So if it's 1 is negative, 2 negative will become positive, 3 negative will still back to negative. And if you have 4 negative words, it will become positive. So these are the negative words you kind of need to watch out when you guys, there are more, okay? So be careful with this. So these are the few, so we're gonna jump this to to question 4 and 5 here. So you guys will figure out what I'm talking about in this case. So as I mentioned in step 4 and 5 here, question step 4 and 5 here is asking us to figure out, are they doing a two-tail, left tail, or right tail test, critical values and p-values, and then after that, what is the decision? So in order for us to do this question, to figure out two-tail, left tail, or right tail test, you have to know your H1, okay? So if you know your H1, then you will figure out, because the H1 will tell us, are we using less than, greater than, or not equal to, okay? So when you read here, you can figure out by looking at the claim statement. This is the claim statement. So this claim statement will give us the H1, okay? So always the claim statement will always give us the H1. So, so what we look for here is the symbol greater than. So we notice that when you have greater than, then so two-tail is used when your H1 is your alternative hypothesis is not equal to. This is left tail and this is right tail. So you notice that this will be a right tail test. The reason why this is right tail is because you are using greater symbol in this case. Okay. So this is how you figure out we have left tail, right tail, or two tail. So in order for us to have a two tail, this claim statement is having equality or equal sign, then you will have a two tail. Otherwise, if your claim is either less than or greater than, then it's either left tail or right tail. So this is how to figure out what tail test we have in this case. Just look at the claim statement in this case. Or look at H1 if they give you the H1. Next is to find the critical value. So in order for you to find the critical value, you have to figure out, is this question is going over? Are you showing? Yes, yes. So this question, you have to ask yourself to find your critical value. Is this talking about proportion, or is this going to talk about the mean? So most don't forget, proportion is a symbol we use is P. Population mean, the symbol is mu. So yes, Rafe, yes, I will go with some questions. So how do we know if this is a population proportion or is that a population mean in this case? You have to look for the symbol P. So if by the claim statement, So if you have symbol P, this is gonna be proportion. Okay. And the next, if you have a symbol mu, so you have to look carefully here. So mu is for the mean and P is for the proportion. So that's why I call you guys to underline the claim statement, because that claim statement will tell us a lot of things. Okay. So this P is for proportion. So that means that we are doing what we call as a population proportion or a normal calculator. And then you have to figure out, are we using a two-tail, left tail, or right tail? So this question is saying it's a right tail test because we're using greater than symbol. So so in this case, we are doing population proportion that is a right tail test. So we're gonna use this in your normal calculator. So you have to go to the StatCrunch to get this information here. Yeah, where's my StatCrunch? Yep. Yes, Rafe, we are, yes, please stay back after class. If you have any questions with your homework or anything, please stay back after class. That's my office hours. I will teach you, I will go over some homework with you. So in order for us to do this is you go to the stat calculators normal. Okay. The mean is 0, central is 1. So when you do a right tail test, you have to use greater than or equal to. So make sure you change this into this symbol, greater than or equal to, because the right tail test. And they will give us an alpha. So by the question here, the alpha is given us by 0.05. So you just put 0.05 in here. Okay. And your shading has to be a right tail shading. And this whole thing is going to be a 5%. And the shading rate one, the white one is 95%. So that's why the alpha is given to us. So now the critical value in this case is this follow. So your critical value in this case is 1.645. Okay. So how do you find this is to do a normal calculator. And then make sure that you use greater than or equals to, and this is blank. And then the next box is 0.05. Okay. And the blank is 1.645. And this is how you find your critical value in this case. Anyone have any questions? Okay. Now, next is to find the p-value. So again, we know this is proportion and it's a right tail test. So when you look at table number two is where you find the p-values. Again, you have proportion or mean, and since this is proportion, we will be going over this part, and it's a right tail test, so it's going to be this. So in this case, we are using the normal calculator where PZ greater than equals to Z score. So again, we're gonna use back the same calculator here for normal calculator for this case, for this question. But the mean is still 0, central still 1. But we still use greater than equals to because it is a right tail test. But this time you have to put a Z score over here. And the question did provide us a Z score. This is your Z score in this case. This is your Z score. Okay. So you will put 2 away. Okay. So again, your shading must be right sides. So this probability is this case. And as you guys know, that probability is a p-value. So so this is how you find the p-value in this case. So p-value, which I short form it to PV. P-value in this case will be 0.0228. How do you find this? Is again using normal calculator. And then now you will have to use 2.00 or 2 in this case. And then your first box and the second box should be empty. This 2.00 comes from your Z score. Okay, comes from there. So that's why the question has to give you that in order for you to find your p-value. questions on how you find the p-value. So this is table 2 that you need to use to find the p-values. And for the critical value, you use table 1. Okay, so make sure you guys know which table to use here. And now we have to figure out the decision in this case. So the decision in this case is based on p-value and alpha. So alpha is this little fish. Okay, some of you are asking what is alpha? Alpha is a little, I don't have the symbol here in my keyboard. So what you're looking for is your p-value, which is found in question, the one that you just did over here, which is 0.0228, and alpha, which is given in the question, it is given to us 0.05. So this is your p-value found in this question here, the one before we just did, and alpha is the one after that. And you notice that this p-value is less than alpha. Okay, 0.0028 is less than 0.005. So so this is your decision. So step number 5 here, to make a decision, you look for if your p-value that you found in here, which is is that less than or greater than? Since this p-value is less than or equal less than to alpha, which is the first one, we will reject the null hypothesis. So your decision in this case will be, we will reject. So in this case, we will reject H0, which is the same thing as a null hypothesis in this case. So this is how we do these 4 things here. What kind of test is this? Left, right, 2 tails. Find the critical value, find the p-value, and figure out your decision. So this is like step number 4 and step number 5. So if you want to figure out all the 7 steps, these are the 2 steps that we will be doing in this case. And we're going to repeat again for question 5, 2 tail, left tail, right tail. So this is where the H1 is given to us as mu is not equals to 2.5. The test statistic is T equals to 2.31 with a sample size of 45. But we're still using the alpha is 0.05 here. So the first question is asking is this a 2 tail, left tail, or right tail? And this question does give us H1. So that means sometimes the question will give us a claim statement. Mostly, I will say 99 to 100% of the questions in that you do it will give you the claim statement. However, sometimes the question did not give the claim statement. They will give you the H1, an alternative hypothesis statement. And we will also use that for that case. So since we know this is not equal to symbol that we use here, so the kind of test that we'll be using in this case is going to be a 2-tail test. Okay, so this will be a 2-tail test. The reason why is because we are using the not equal symbol. Okay, so make sure you guys know this. So this is important. That's why every time you see me highlight things, make sure that you you know that this is super important in this case. Okay. Next, you have to figure out, is this proportion or mean? Because in order for you to find the critical value of p-value, you have to either figure out proportion or mean. And again, you can tell very easily this is actually have this symbol, which is called the mu symbol. So in this case, this mu symbols is telling us that we are doing the population mean in this case. Okay. So now we have to do the 2-tail test for the population mean. So in this case, we're going to find the critical value again. So with a 2-tail test and it's going through population mean. So again, to find the critical value, you have to refer back to table 1. So back to table number 1 here. So table number 1, we got, again, you have to pick one of these, either the proportion or mean. But this question already states they are mean because we're using mu. And then the next one is, are we using 2-tail, left tail, right tail? Because that is a not equal sign. So we're going to use 2 tails. So this is what we will be going over. So we have to use a T calculator. So this is not the correct calculator. So we're going to use the T calculators to find this question. But this one, make sure that if you want to use greater than or equals to, then you will get a positive answer. And also make sure that your alpha in this case is divided by 2. Okay. And we know the question already give us alpha is 0.05. So in this case, we will divide this by 2. But we still need to figure out the degree of freedom. That's why they give us the sample size is 45. So when you do the T distribution, the degree of freedom in this case is n minus 1. Okay. So that means that n is a sample size. So 45 minus 1, it becomes 44. So the degree of freedom in this case is 44. And the alpha is 0.05. And the reason we divide by 2 is because of the two-tailed test. So when you compute this, your critical value for this question in this case will be plus minus 2.0154. Depends on how many decimal places you need. But the plus and minuses is important because it's a two-tailed test. The picture that you see here is only giving you right tail, and the left tail is going to be exactly the same, but it's only going to be on the negative side. Okay, so I'm going to put it down how you find this critical value CV. So we will use a T calculator. With degree of freedom of 44. Okay. And then you will use Px greater than or equal to blank, blank, blank. That means the first box is blank. And the second box that you have here is 0.05 divided by 2. Okay. And this will give us the positive side, and you need to just figure out the negative side for this case. Okay. Questions, anyone? Next, question number 5. Now we finish out doing critical value. You have to find the p-value. So short form is PV. Given you have to use table 2, and we are still doing the mean with the two-tailed test. So if you look at table number 2 here, which is this one, that is finding the p-value in this case. Again, we got choices, proportion or mean, and because this question is doing mean, so we are picking this. And then are we doing two-tail left to right tail? We are doing two-tail test. So that means we are still using the T calculator, and we are still using the same degree of freedom of n minus 1, which is 44 in this case. But you're going to use this case and make sure that because it's a two-tail test, once you get the value, you have to double it. The reason why you double it is because you only found one side of the p-value on the right side or left side. So because it's a two-tailed test, so it should have the same area on the other side because it's symmetrical. So that's why you have to double, or you add the same twice, in this case double it. So that's why you see when you do a two-tailed test, you double your p-value. Okay. So what happens here, class, is let me take a look at it. Oh, your t value given us is a positive. So since it's a positive, we will use the positive symbol, greater or equals to, and it's given us by 2.31. Okay. So this is how you figure out your p-value here. And then when you compute, now this is not your answer because you have to double it. Okay. So the p-value that you have in this case is going to be given us by 0.0128 times 2. So don't forget to times 2 here. Otherwise, you get it wrong in your homework and your test. 0.0128 times 2. 0.0256. So this will be your p-value in this case. And again, you have to use a T calculator to find this with degree of freedom of 44. Okay. And then now you will have to use greater than or equals to because 2.31 and for your first box, and the second box to leave it empty. So because that is how you find your probability or p-value in this case. So this is how we do question 5 to figure out your p-value using this table number 2 here. Does anyone have any questions for this case? So the next one we have is the decision. So again, the decision is based on p-value and alpha. So the p-value that you found in this question is going to be the one that you just multiplied by 2, 0.0256. And alpha in this case is 0.05. So this is where students, you need to know which one is smaller than or which one is greater than. I hope you guys still remember how your middle school or elementary school teach you about the alligator who eat who, right? The alligator eat the big one, right? I believe, the bigger number. So so since the alligator eat over here, then the symbol we use in this case will be less than. Okay, so make sure you guys know all this because if you use greater than, if your decision is wrong, it does have what we call as a domino effects. Means if your beginning is wrong, everything after that is all going to be wrong. Okay, but you won't get 0 in the test. Okay, you only take maybe 1 point deduction in the test because you make a mistake in step 4 or step 5. Okay, and I know I will still look through the whole questions and see. I know you read wrong already. I will see if you still make the correct conclusion and the correct. Everything is correct based on the wrong mistake you did in the early on, okay, based on the mistake. So yeah, it's fine. I mean, no one is perfect, and as I mentioned, and if you make a mistake, I won't just give you 0 because you did understand the word. You just make a mistake in this case, which is fine. Okay, it's not the end of the world yet. So the decision in this case is p-value is less than alpha. So the alligator eating the big number. So the decision here is same. So same as this. So if your p-value is less than alpha, we will reject the null hypothesis in this case. So your decision here is the same as the one on number 4 because your p-value is less than alpha. So this is how we make a decision in this case. Questions? This is tough. I didn't say it's easy, okay? But you will start getting bored next week because I've been doing this over and over again. The last part that we do here in question 6 here is to make a decision and the conclusion. So this question wants us to do 2 things, decision and conclusion. So decision is what we just did just now over here. If your p-value is less than alpha, we reject. If greater than alpha, we fail to reject. That is the decision. Conclusion is that 1, 2, 3, 4. If you remember table 3, 1, 2, 3, 4 here, that is the conclusion that we are talking about here. So make sure you guys, I will show you how to figure out this. So please pay attention here. So decision, conclusion. So conclusion is where you're going to use table number 3 in this case. Okay, very important. So first thing is we underline or highlight the original claim. That is the most important thing to do here. So the original claim saying that the percentage of blue M&M is greater than 5%. So that means that the people who make M&Ms, Mars, saying that if I make Mars, it has this in the bag, the blue candy that inside in the bag has to be more than 5%. And I'm talking about not just the bag in Minnesota, I'm talking about the M&M candies bag for the whole entire world. Okay, so the whole population, in other words. So this is the claim statement that we have in this case. So we have to make decision. So how do we make decision in this case is, again, p-value and alpha. The good news is p-value is given to us here. So this is your p-value. So you do not need to find it like what we did last time here, a double or something else. So we just go straight to the decision piece here. So in order for us to make the decision, again, you look for p-value and also your alpha. P-value in this case, oops, I just block it, is given us by 0.0789. And alpha in this case is given us by 5%. Okay. So in this case is a little bit different story now, because if you do the alligator, 0.789 in this case is actually is greater, right? So 0.789 in this case is greater than 5.05. So we will not, the decision here is we will, now some of you say will not reject. So what we do is we fail to reject, okay, the null hypothesis. Okay. So instead of doing we will reject the null, we will say we will fail to reject, because the reason why we make this decision is because of your p-value that you given or found is more than alpha in this case. Okay. So this is the decision that we will make. Now, conclusion. So the conclusion here is have that 1, 2, 3, 4 pickings. So if you look at the diagram here, you have to figure out if your claim statement has equality or the claim statement has the inequality. So how do we know this is the claim statements? So you will have to read this claim statement again and figure out if this claim statement has equality, equal sign, or inequality. Okay. And this is the claim statement that we have. And when you read this, you have the word greater than 5%. So we find out that because of the word greater, it is inequality. So your conclusion in this case, so say you use claim is inequality. That means your claim in this case has the word greater than. So this is inequality. And then your decision based on the blue one that you just did here, the step, the one that you did earlier on, we fail to reject. So fail to reject H0. This is based on the decision that you make early on here. Okay, so that's why it does have domino effects. If you make this mistake, this is going to be a wrong one. So claim has greater than and fail to reject. So let's take a look how this will go. Okay, so we have claim has equality or inequality. So we have this. So this is the right track we're going to go. We're not going to go through this track for this question. And then we reject or fail to reject. We fail to reject. So we will take in conclusion number 2 in this case. Let me repeat. This question says that we have greater than 5%, something like that. So the claim here has a greater than symbol. So it's not this. It's going to be this side, the right side. And then you figure out, do we reject or fail to reject? Our decision says we fail to reject because our p-value is greater than alpha. So we will pick this conclusion number 2. And what is conclusion number 2 says? This is the conclusion number 2 says. There is not sufficient evidence to support the claim that ... Now in the test, do not give me ... like this. You have to replace those dots by the original claim. Remember the one that I highlight in yellow early on? So you just copy that whole original claim and stick it in there. Copy and paste. Okay. And yes, for those students who are lazy, you need to write this out. You cannot be lazy and just say, oh, this is the original claim, like me drawing arrows, like what I just did, drawing arrows here and there. So do not draw arrows in your test, because the more arrows you draw, the less points you will get. Okay. That means don't be lazy. Write it out. So how's your conclusion work in this case? We will pick number 2. You do not, some students say, David, do I need to say number 2 in the test, or number 1 or number 4? Oh, there are 4 questions, 4 choices. No, you do not need to tell me what number you use. The reason why I tell you to use number 2 is for your reference or your review when you go over this in your homework and or your tests. Okay. There is not sufficient evidence to support conclude to. Let me see. There is not sufficient evidence. Let's see what's number 2 says. There is not sufficient to support the claim. Okay, I'm gonna to support the claim that now the dot here, now you just copy and paste this highlight in yellow. That the percentage of blue M&Ms is greater than 5%. So this is the dot that you need to do. So you copy and paste it. So so this is how we do this conclusion here. So very super important in this case. Anyone have any questions here? I'm going to take some attendance here, so make sure you go for attendance in this case. Okay. This homework is going to be due on Wednesday, again next week Wednesday, which is the 18th, I believe, right? I think so. It's the 18th. Yep, no, 17th. The 17th, not the 18th. The 17th. So we're gonna go to the first the question number 3 to identifying this, what we call as type 1 and type 2 error. Okay, so I did not go through this with you guys, so I will be going over this with you guys here. So what is type 1 and type 2 error? So this is what we call the type 1 and type 2 error. Type 1 error is called the alpha, which is the same alpha that we use the significant level. Remember the alpha 5%, 0.05. So this is the same as your type 1 error. What is type 1 error is? Type 1 error is where you mistaking of rejecting the null hypothesis when it's actually true. Okay, so you are rejecting the null hypothesis when it is actually true. That is a type 1 error. Type 2 error is called beta, is where you mistaking to fail to reject the null hypothesis when it is actually false. Okay. We have name for this if you don't like in the medicine world or in the doctor world or in the hospital world. Type 1 error in this case is called false negative. Okay. And type 2 error in this case is called a false positive. So what is false negative means? False negative means that let's say you go to the hospital and you take a result. Let's say take a test. Let's say you take a COVID test, okay? And you do your COVID test and the result can be negative and it can be positive. So doesn't mean that if your result is negative, it's negative. Or you're positive, okay? So in this case that when you have false negative, in this case is, no, sorry, the other way around. This is false positive because it's true. Sorry. This is false positive and this is false negative. Where did we spell this one? No, that's correct. So we will be so your result can be positive, your COVID result, and a lot of people see the result is positive doesn't mean that you have a virus. So so usually people retest it. So when you have a false positive means that the result came up positive, but you do not have COVID, in other words. Okay. So that is usually you can fix this by retest again, because usually when you test positive on any test, you probably will have, all right, we're gonna do one more time, and if you do it 3 times in a row and all 3 is positive, then for sure you will get the COVID in this case. But if you just get 1 positive and then you test 2 other times and they came up negative, then the first test is a false positive, means the positive is not correct. And that is what we call as type 1 error, alpha in this class, where you're rejecting the null hypothesis when it's actually true. Then we have the false negative. Well, false negative means the result came out negative, but you actually have the virus or have the disease. So this one is very difficult because people, when you go testing and you say, and your result came out negative, how many of you retest if your result came out negative? Majority of you were like, no, I'm not going to retest because the result came out negative. I don't have COVID. And then a few days later on, you begin to get sick, you know. So that result is, that test that you just did, the result is a false negative, means that the result is negative, but you actually have the virus in this case, or have COVID in this case. So that one is very difficult to detect because no one retests or redo anything if the result is negative, right? Until you have next few days you're feeling ill, then you kind of, you know, you're thinking about, oh, is that wrong? Something wrong with the test? Okay. So that is called a type 1 error. So in order for us to do this kind of questions, make sure that you use exactly what I highlight in yellow here. But the only thing is that you have to replace the null hypothesis with the context of the question. Okay. Or in this case, context of the question. And do not forget that the null hypothesis here do use the symbol equal sign. Okay, so remember the null hypothesis H0 always have the equal sign symbol. So make sure that when you put it down as equal sign symbol. Okay, so so this question is given us by finding type 1 and type 2 error given a corresponding given claim. So the percentage of college adult, I'm going to highlight this because this is your claim here. Always highlight, please, if you want to bring a highlight to the test, bring it. Okay. So so this is a percent, the claim here is the percentage of college students who consume alcohol is greater than 70%. So this is the claim given us. You have to figure out what is type 1 and type 2 error. But when you look at type 1 and type 2 error in this case, you find out that type 1 and type 2 error is based on the null hypothesis H0. Okay. So we're going to write down what is the H0 here. So that will help you to figure out what is the null hypothesis. So the H1 is given us by P is greater than 0.70. And how do I know this is a P not mu? It's because we use percentage. So how do you write this as the null hypothesis? So the null hypothesis is actually the H0. It's exactly the same as this H1. The only difference is you just need to change your your less than or greater or equal to an equal sign because your null hypothesis is what we have to figure out. So using equal sign in this case. So when you do the type 1 error, okay, so you just copy down what we have here, which is rejecting the null hypothesis when it is actually true. So type 1 error says that you rejecting the null hypothesis when it is actually true. Okay, so what we do here is we just replace this null hypothesis, which we know is H0. And the H0 in this case is P is equals to 0.70. Okay, so this is the null hypothesis that we have for this claim. But we do not want this symbolic form. We want in the word form or in the document words form. So in the what is the context? So P in this case is the percentage of our college students in this case. So in this case, P will be the population percentage of college student who consume alcohol. So that is your P. And then is equal to 0.70 when it is actually. So this is how we do your type 1 error, is we take the definitions that you have in here, and then the one that I had in yellow, and the one I circle in purple, the null hypothesis. will be changed to the context of the question in this case. Same thing with type 2 error. So in order for us to do what is a type 2 error in this case, type 2 error in this case, if you look at the highlight I have, is failing to reject the null hypothesis when it's actually false. So this is failing the null hypothesis when it is actually false. Yep. Some of you asked me, David, is this coming up in your finals? No, this is not coming up in your finals, so you do not need to like write all these notes in your one front page cheat sheet. It's going to be in your homework in this case. So how do we do this? Same thing. Change the null hypothesis to what we have here, which is given us by P is equal to 0.70. And what is P stands for? P stands for the population percentage of students who consume alcohol. So this is your P. So this whole thing is your that I highlight here. I'm going to copy it. Then copy this. Let me see. Oh, I just rewrite this. So just read. So P will be the population percentage of college students who consume alcohol is equal to 7.70 when it's actually false. So this is how you draw the type 2 error here, how you write it out. So again, I mentioned here for these two types, type 1 and type 2 error, you need to know what is your null hypothesis. Where you find null hypothesis is looking at a claim statement, and you just need to change the greater symbol to become equal to symbol. So you just need to change this to become equal to, and that will give you the null hypothesis in this case. So this is how we do 8.1. This is very difficult, so I didn't say it's easy, and I will again suggest you to come seek help if you have any questions. Okay. We're gonna do a little bit of 8.2, and then we do not need to. Then we'll go through. We'll stop. So in 8.2, this time in 8.1, we separate the procedure into 7 individual steps. So in this section, we will combine these 7 steps into one whole procedure to perform a hypothesis testing. So for this question class, we will be doing a lot of all the 7 steps together. And once you do that, then students will get the pieces that we did in 8.1. Okay. So how do we do in 8.2, we do a test of claim for the population proportion P, where again, we are doing a lot of categorical variables in this case. We are not doing quantitative. So that will be for proportion case. So there are a few notations you need to know for here. So for this case, N in this case is a number of trials, or sometimes we call it as a sample size. So how many people they survey. X in this case is called the number of success. P hat in this case is called the sample proportion. Okay. Q hat in this case is called the sample failure. So there are formulas to find sample proportion. Sample proportion can be found by taking X over N. Q hat, which is a sample failure, can be found by taking 1 minus P hat. So if you know the sample proportion, let's say 20%, and then the sample failure will be opposite 20%, which is 80%. Okay. Then we have more values in this case. P0 is called the claim value. Again, this is found in the claim statement. So usually as a claim statement or claim value, you have a number. Like this claim statement has the 5%. So that 5% is your claim value in this case. So that's why I call it underline the claim statement. So you know that that value will be called a claim value. Alpha is your significance level. So you just need to, this is also usually given in the question. So make sure you figure it out. For the P in this case is population proportion. And then Q in this case is population failure. So again, if you notice here, there are two types of proportion here. One is from the sample, one is from the population. And again, I mentioned what we did so far here in inferential statistics. We always take the sample and we will predict the population. Okay, so this is what we do the whole the world of statistics here. We always do that. Okay, this is how we make inferences or we make prediction in this case. Okay, so that's why who is winning this election? No one can tell me. Not a lot of people can tell me who will win this election because they can project or they can predict it, but the prediction is not 100% accurate. Okay, so until the result, until this November, then until the populations who vote, then we will know. So this will be the notation. So in StatCrunch, you need to know your N, you need to know your X, you need to know your P0. So these are the few things you have to know. And you also need to know, are we using less than, greater than or not? So this is quite a few, we'll talk about that in 8.1. So make sure you know which one to pick. Requirements. These are requirements the same as what you did in proportion. So if you remember the requirements for proportion, simple random sample, binomial, at least 5 success and 5 failure. This is the requirement check for population proportion. I just copy and paste it from that page. So it has to be a simple random sample, binomial, at least 5 success and 5 failure. So this is exactly the same as 7.1. Okay, so you were asking that. StatCrunch, for StatCrunch, we are doing stat proportion, stat one, stat sample summary. Wait a minute, this is exactly the same as what we just did in 7.1. Okay, yes, you are correct. In 7.1, when you find the confidence interval, we are doing the same thing. What do you mean by do we need to write this down roughly?
Like, should we put it down on like a note sheet, or will we have like it supplied to us on the
You mean the
direction?
requirements?
No, the
StatCrunch?
yeah.
Yeah,
No,
no, StatCrunch, I will give you a syntax, like what you have in your midterm. You will get a one note.
What about the notation as well above?
Notation,
right
no, just the StatCrunch.
Okay.
Just the StatCrunch. So the StatCrunch is the same as doing confidence interval, but you just need to perform the hypothesis testing in this case. Okay, so that will be the StatCrunch for this case. So that means that you will go to you will go to stats, proportion stat, one sample with summary. And remember last time we do this in 7.1, you put your X and N, but then we pick the confidence interval. But this time you don't pick the confidence interval, you pick the hypothesis testing. So you pick the first one. And this number that you put in here is your claim value. So if you're doing 3% or 10% or 15%, that's what in the claim value state. Or the one with the alcohol one is 70%. So that will be the claim value is. And then in your alternative hypothesis H1, if you scroll down, there are 3 options. So a lot of students did not pick the correct one. So make sure you pick which one we are doing. Since we are testing the claim statement asks us to test greater than 70%, then we will use greater than. If a claim statement tests for less than 70, you will use for less than 70. If a claim statement says it is equal to 70%, then you will use this. And then you hit compute. And I'll just give you an example so you guys can see it. I just simply type some numbers down here. And when you hit, when you hit compute, you will find out that the results on this case is this is your hypothesis statement H0 and H1. So sometimes you just do the StatCrunch work and then you can figure out doing the whole 7 steps because the hypothesis statement is right here. Okay, so I usually call you guys to write it to compare it. Okay, and then what happens to the results? In the results, you will get the count. which is the X, total, which is the N, okay? Sample proportion, which is the P hat, which is if you take X over N, you will get that number. Again, we don't do standard error. So this is very similar to the the confidence interval that you guys did in 7.1. The only difference here is you don't see lower and upper. Okay, so last time you see lower and upper on the last two. So this last two is been changed to z-stats and p-value. Okay. So the p-value is p-value. So that's why the good news is that if you do it this way, your StatCrunch automatically calculate the p-value. So you do not need to go to table number 2 to figure out the p-value. And moreover, they will double it for you if it's a two-tailed test. So you do not need to worry about doubling the p-value here. Okay. So so they will give you this. So in the results, you will get the p-value, and also you will get this z-stat. This z-stat is called the test statistic. Let me repeat. The p-value is on the very end. The one before that is called the z-stat. It's called the test statistic. And the reason why there is a letter Z in front is because this is a Z distribution where you will, we use a standard normal in this case. And then if you do the mean, you will see the Z-stat here will change to become a T-stat. The reason why it's T-stat is because your test statistic is a T value, where you use a T distribution to do this case. So sometimes, so your StatCrunch will actually give you 2, 3, and 4. 2 as a hypothesis statement, which is the one over here, okay, the first 2 lines. And then the Z or the T is found in here, this one that I highlight in blue here. If you see Z means it is a Z distribution, and then T is T. P-value is this number, which is I highlight in blue, that is your P-value. So this means that the P-value is 0. So if you see a P-value that have this symbol less than 0.001, means it's 0. And then the test statistic is given us by next to it. So we call it z-stat. So this is how we do this in the StatCrunch. So so in this case, make sure here are the 7 steps, same 7-step procedure. So requirement check, which is, I should highlight this in yellow, which is this 3 requirement check. And then you have to do a hypothesis testing. Oops. You have to do the hypothesis testing in this statement in this case, where you have to give me your H0 and H1. Sampling distribution, make sure you will use Z for this case. The reason why we will not use T is because this is mean. This is proportion, sorry, not mean. This is sampling, this is doing population proportion. So Z-stat is used instead of T. And then after that, you will be p-value and test statistic. So this is where your StatCrunch will be. So this usually you can refer StatCrunch. So StatCrunch has this. Okay. Then alpha is the next thing. You don't find it because alpha is given in the question. So make sure you know that this is given in the question. Don't find this. Okay. So alpha is given in the question. We call alpha significant level. So it is given in the question here. So you do not need to find it. And then the decision, this is your decision here. So your decision is either you reject or fail to reject. Okay. This is the same decision we made last time in 8.1. Yeah. So if your p-value is less than alpha, we will reject the null hypothesis. Otherwise, if your p-value is greater than alpha, we will fail to reject. One is reject and one is fail to reject the null hypothesis. And then step number 6 is the conclusion. Again, the conclusion is that 1, 2, 3, 4 that we mentioned there. So this is again the same table 3 that we have in 8.1. I just simply copy and paste it. And then the last one that we have here is to answer the question. So usually the answer to the question can be, as I mentioned, based on the conclusion you draw. So if you make this conclusion, means yes. If you make the second and third conclusion, is no. Last one is yes. Yes means valid, good, true. No means is the other one. Okay. Or sometimes I can ask you for other factors. So make sure you read the question carefully and figure out what kind of questions they will ask. So these are the same 7 steps over and over again that you will do in chapter 8, 9, and 10. So you will get a little bit bored after we finish next week class. Okay? So that's it for today. We did not start any example at all in this case. So actually your homework in this case is only up to 8.1. So 8.2 is not due on next week, Wednesday. So you only have 3 homework due on next week, Wednesday, which will be 7.1, 7.2, and 8.1, which I will tell you that it is not easy anymore. This is a little bit more difficult. So I will hardly, again, seek help. Or if you have any questions, please stay back after class, which is now, to go over some questions here, right? So that's it for today. When you come back on next week, Monday, we will be going over 8.2, the whole 7 steps of doing hypothesis testing, all put it all together. So you'll see it more clearly by that time, okay? Seek help if you need help. Right, that's it for today.